Good evening and welcome back to Zeus Explains. In today's video, I'm going to be going over a few of the hard questions for tomorrow's AMS. Two of them from the quiz. Yeah, I'm only going to be solving two questions since the rest of it, the quiz is kind of easy. You know, the golden rule, ME1 is equal to ME2, and a few definitions, conservative forces, gravitational energy, that sort of thing. So if you don't know them or you forgot them from last year, just go over some notes, you'll be fine and dandy. Now, I'm going to be solving number 4 and number 8, starting with number 4. A stone is thrown vertically upward from the ground level with a velocity of 10 meters per second. Okay, the hg is equal to 10. Now, the kinetic energy of the stone is equal to its gravitational potential energy at a height of blank. So we need to find the height at which EK is equal to UG. Let's activate the pen. So EK is equal to UG. Now here I'm going to eliminate one of the variables. So basically it's that ME, which is EK plus UG, is going to be either 2EK or 2UG. Here, since they asked for the height and UG is a function of H, so I'm going to be saying that ME is 2mgh. If you don't understand how we got that, so ME is equal to EK plus UG. And since EK is equal to UG, which is one of the conditions in the question, then ME is also equal to 2UG or 2mgh. Now that point, let's call it ME2, the mechanical energy at that point. And ME1, the initial mechanical energy, is going to be equal to ME2 because we don't have friction, we don't have any non-conservative forces here at play. And assuming that the ground is our reference, ME1 is just going to be equal to half mv0 squared. Setting that equal to 2mgh, first of all, the m cancels out, v0 squared is given, g is given, and so the only thing we need to find is h. H is basically going to be equal to v0 squared over 40, since g is 10. v0 squared over 40, which is 10 squared over 40, 100 over 40, over 40, which is equal to 2.5 meters above the ground. So here, activating our eraser, param, 2.5 meters. Okay, now moving on to number 8, which is a little bit harder. A cylinder has a mass of 20 kilograms and is released from rest when h is equal to 0. So it's released from this point over here. Let's also activate the pen. This beautiful green color. Okay, so it's released from here. Each spring has a stiffness K is equal to 40. So as you can see, there's two springs. They're identical, same K, and a length of 2 meters. This is L0. Right, so if you recall that X, the extension, is equal to L minus L0, the natural length. And take G is 9.8, okay? What is the speed of the cylinder when H is equal to 3? So at this position here, this is the cylinder. Okay, H is equal to 3. And we need to find V. So first of all, ME1 is equal to ME2. As always, there are no non-conservative forces, no friction involved, making our lives complicated. But before we do anything, they gave us L0, but they never gave us the X. Where's my cursor? They never gave us X, which is the extension, which we need in our formula for UE. So thinking a little bit ahead. And so we need to find it. Now we know that L0 is 2 and H is 3, so this is also going to be equal to H, which is equal to 3. This little leg that we drop this altitude, and here we have a right angle, and then the length of the spring is equal to the final length. Now since x is equal to L minus L0, let's write that down. X is equal to L minus L0, and so L is equal to x plus L0, so 2 plus x. And so on this right triangle over here, applying Pythagorean, 2 squared plus 3 squared is equal to 2 plus x, sorry, squared. My bad here. And so this is going to be equal to 13. And so x is equal to radical 13 minus 2. Now we begin with the mechanical energy. ME1 over here, the initial, is equal to ME2. Now ME1 is kinetic energy, gravitational potential energy, and elastic potential energy. EK is 0 since it's released from rest, simple. Picking the reference to be the horizontal line where it was located, so UG is also 0. And UE is 0. Why? Because the length of the spring is equal to its natural length. There's no extension, so there's no x. So ME1 is 0. Now ME2 similarly is also equal to EK plus UG plus UE. EK is equal to half mv squared. No idea why the purple text was gone. Okay, EK is equal to half mv squared. V is what we're trying to find, the speed. And then UE, sorry, that was here, it's second, here, so UE is half kx squared. X, we found it just like a minute ago. Minus mgh. Why minus? Because it's below the reference that we chose. Right, so it's below it. Now substituting, we have h3, we have g 9.8, m is 20, x is radical 13 minus 2, and we need to find v. And so we're gonna get that 10v squared, or so 0, is equal to 10 v squared plus, so oh sorry, not half kx squared, since you have two springs. Again, my mistake, making a lot of mistakes today, it's late and I'm tired. Is equal to kx squared minus mgh. So k is equal to 40 radical 13 minus 2 squared minus 20 times 9.8 times 3. So simplifying a little bit, and so we whip out our calculators. 13 minus 2 squared and we get that it is minus 485. So this, the expression written in blue, equates to minus 485, and so 10v squared, I continued writing here on the left side, 10v squared is equal to 485. Solving for v, we get that v is equal to 6.97 meter. Where's my cursor? Oh, okay, sorry. V is equal to 6.97 meters per second. And that is it. Sorry for the late upload and the very little number of questions. Next week, hopefully, I'll release it ahead of time. And that's it. I hope I was able to help you, even if just a little bit. And remember that all feedback is welcome, positive, negative, neutral. اللي بدكن إياه. Feel free to leave a comment or text me, talk to me. حيلا شي. Recommendations are open يعني. And yeah, good luck in your exam tomorrow. Have an amazing evening. This is Zeus Explains.